Lesson 6.2, Properties of Parallelograms. So when I teach this lesson in school, I have my students do the work. Of course, I'll do it for you. First things first, define a parallelogram. Parallelograms usually drawn like this, and it's a simple definition. It's a quadrilateral. With both opposite sides parallel. And that's what these mean. Same thing with the the arrows on the other sides. So that's a parallelogram. Now, I have people look it up, but if you look at a parallelogram, you draw a diagonal in there. By alternate interior angles, you have this. By reflexive, you have that. And then since the other sides are parallel, you have this. So you learn that both these triangles, triangle ABC is congruent to triangle CDA by angle side angle. Once you know that, then all the other properties just come into play. Due to CPCTC, you know that BC is congruent to AD, and AB is congruent to DC. And the way we say that is both pairs of opposite sides are congruent. For the same reason that the two triangles are congruent, you could also say that angle A is congruent to angle C, and angle B is congruent to angle D. So again, both pairs of opposite angles are congruent. And since we have parallel lines, we know that angle C, measure of angle C plus measure of angle D equals 180 degrees. Same thing goes across this way. Measure of angle B plus measure of angle C equals 180 degrees. And the simplest way to state that is to say consecutive angles. That just means any pair of angles that are next to each other. These, or these, or these, or these. Consecutive angles are supplementary. So this gives you lots of great math problems. 60 degree one angle, 120 degree another angle, so on and so on. Now, you can do these problems a couple of different ways. So I tell you it's a parallelogram. And by the way, we would say this means parallelogram. It's that little shape. It's not a rectangle. It's not a square. It's always a parallelogram. We don't use any other shape that's similar that could be confused with it. It means parallelogram ABCD. So if I say this is 60 degrees, figure out the rest, you say, well, the opposite's 60, and then any pair add up to 180. And all of them add up to 360. So there's a lot going on here. And last but not least, what can we say about the diagonals? Well, if you look at these, you've got alternate interior angles. We've already proved the opposites. And then more alternate interior angles. So we'll end up saying they're congruent. Triangle, we'll put a little E in there. BCE is congruent to triangle DAE by, and there's lots of different ways to do it, but we'll just go with angle side angle. So therefore, this piece is congruent to this piece, and this piece is congruent to this piece. And the simplest way to describe that is to say that the diagonals bisect each other. So if we have 9 here and 6 here, we'll have 6 here and 9 here. Already talked about this. We notate with a little shape that means parallelogram. And try some practice problems. Not here, but on your own. Good luck.